Now, we've talked about how we can price a simple European bond option by assuming that the underlying bond follows a log normal process, and we have a readily available a closed form solution to get the price of the option. Now, let's look at some of the details related to that. So first of all, what if you're being quoted a yield volatility rather than price volatility? So in the last example, we have a 9%, which is the forward bond price volatility. Now, if you are not given the bond price volatility, but instead quote a percentage on the yield volatility, you can always use the duration to convert it to a bond price volatility. So essentially, there's a relationship between the percentage change of bond price and the percentage change of yields. So therefore, the bond price volatility is really the yield volatility times the duration and times the yield and times -1. So this will allow you to convert a yield volatility to a bond volatility. Okay, so that's one piece of that. The other piece is when it's appropriate to use this formula. What are some of the drawbacks for this particular approach? Well, this approach is very simple, right? It has a closed form solution, so you can calculate a price very easily with very little numerical computation complexity there. But a bond is different from a stock. So this Black's approach for forward price on stocks may not always be appropriate to be applied for underlier that is actually a bond. Now the difference is that this is what we call pull to par. A bond at maturity has a very definite value. A stock has no maturity, and there's no definite value at a particular time. Bond is very different. At maturity, the face value of the bond will be paid to the investor. So, and that value is known. And when that payment is going to be made is also known. So because of this, we see the consequence of that is this sigma, the volatility of the bond, is actually not a constant over the life of the bond, particularly towards the later part of the bond when it's close to maturity. And as the bond approaching to maturity, the value becomes more certain, and the volatility of the bond process will actually decrease over time to 0. So the assumption that this volatility parameters are constant, which allows us to use the Black's approach, would not be a good assumption when the maturity of we're using a bond that is very close to its maturity. So in other words, what's appropriate to use this simple formula or simple approach to value European bond option is to apply it to a bond that is far away from its maturity date. So in the example that we had earlier, we're basically are looking at a very short term, like a 10-month call on a bond with very long maturity date from today. So, the bond is almost 10 years away, and we're only looking at 10 months from today. So in a situation like this simple approach will be a good approximately will give you a good approximation of what the European bond option value is.